Hello, so we're going to talk about topic 3.4, differentiating inverse trig functions. So this is pretty much just a few more formulas that you're going to have to memorize. I would like to start by showing you the why. AP or College Board isn't necessarily going to have you prove any of these inverse trig functions. If you want to fast forward through this, you can, and just get to the derivative formulas. However, I do like to always show you the why and how this always works. So for example, 1, if I let y equal arc sine of x. Now, 1, I want you to understand arc sine is the same thing as saying sine inverse. Okay, so sine inverse of x. This is my inverse trig function. How could we find dy dx without using an inverse trig function, right? So here's the idea. If I were to say y equals sine inverse of x, okay, I can instead, I can say if I take the sine of both sides, right, that actually cancels out the sine and the sine inverse on the right hand side of my equation. And on the left hand side, I'm left with the sine of y. Okay, now let's say on my triangle, I know the sine of y equals x. Well, sine is opposite over hypotenuse. So if y is my angle, then I know the opposite has to be x and the hypotenuse has to be 1. Okay? Now I'm going to come back to that in a minute. But again, sine is opposite over hypotenuse. The inside of my sine is my angle. And then whatever it equals to has to be opposite over hypotenuse. Now, if I take the derivative of this, the derivative of sine is cosine. Leave the inside the same, but using implicit differentiation, the derivative of y is a dy over dx. Okay? And then the derivative of x is 1. So I want to solve this for dy dx. So I'm going to say dy dx is now going to be equal to 1 over the cosine of y. And I want to show you where this cosine of y comes into play, because cosine of y is adjacent over hypotenuse. So if you come back to my triangle, if this is x and this is 1, then using Pythagorean theorem, I know this has to be 1 minus x squared. So if I do the cosine of y, this is saying 1 over the square root of 1 minus x squared, and that is the derivative of sine inverse. Again, that's the little proof. Now, again, I don't expect you to have to be able to prove that on College Board, but I do want you to understand how I get it, right? If I were to scroll down, these are the trig functions, the 6 inverse trig functions that they require you to know. Now, I'm going to kind of highlight some of them. Sine, cosine, tangent, cotangent are really the ones that you need to know. Secant and cosecant are just some extras. I want you to see them. I want you to have them in case, next year in college, Calc 2, Calc 3, those come up. However, College Board doesn't typically test arc secant or arc cosecant. So again, I want you to look at my gray table here. You can see it a little bit clearer. The difference between the gray table and the blue table is the blue table has an expression inside. It's more the chain rule side. So you can see that they're the same formula, but for arc sine of u, that's going to be some sort of expression of x. We're going to have a little chain rule for that, and I'm going to show you that with the problems that come in the future here. So if I were to do this, now I wrote them on the next page just so I have them for reference, but if you look at example 2, I want the derivative for arc sine of 2x. Well, I'm going to use, sorry about that, guys. I'm going to use the derivative formula for arc sine. So I'm going to start with the derivative of arc sine, which will be a 1 over the square root of 1 minus quantity 2x squared. Okay. Now, the only thing is I never took the derivative of the inside, and that's where the chain rule comes into play, and I get 2. So when I take this derivative, I get 2 over the square root of 1 minus, and 2x squared is really going to be a 4x squared. This is my derivative. Okay, so you can see kind of the resemblance between that and what I circled in the derivative formulas. It's 1 over the square root of 1 minus whatever is in that quantity squared, but then you have to multiply by the derivative of that quantity, and that's where that u prime comes from in my formula. In this case, it was just a 2. All right, so let's do it again. Practice makes perfect. Derivative of arctangent or tangent inverse, right, is we're going to use this guy. All right, so the second one here. 1 over 1 plus whatever's in those parentheses. So in this case, 3x squared. But then I need to multiply by the derivative of the inside, which is a 3. In this case, I get 3 over 1 plus 9x squared. And that is my derivative. Okay, it's that easy. Now, again, if you want to use these gray ones for reference as kind of a quick guide to how to take the derivative, just don't forget your chain rule, okay? So the gray ones may be a little clearer on what that derivative looks like because you can see 1 over 1 plus whatever it was squared. Just don't forget your chain rule, okay? Let's go to C. So now if you take a look at C, I also have tangent inverse of square root of x. So it's just like B, arctangent and tangent inverse, same idea. So I'm going to say a 1 over 1 plus square root of x squared. But now I need to take the derivative of the square root of x, and this is x to the 1/2. So I'm going to get a 1/2 x, lower the degree to now a negative 1/2. So I'm going to have a 1 over 1 plus x, right? Because square root of x squared is just x, times a 1 over 2 square root of x, because the negative exponent would bring it to the bottom. And if I make that look a little nicer, I'm going to have a 1 plus x times a 2 root x, all on the bottom. This would be my derivative. Okay? Now, one that's not really tested as often, D is a secant, right? So I just kind of threw it on here for the fun of it. And also, there's just a ton of chain rules. So D is obviously a beast in itself. But we'll take it one step at a time. So I'm going to take the derivative of the squared. So I'm going to say 2, keep everything on the inside the same, right? To now the first power. But now I want to take the derivative of secant inverse, which is going to be a 1 over, make sure I got it right, so we're using this one here, 1 over the absolute value of e to the 2x times, okay, I'm looking at my secant at the very top of your screen, the square root of, of e to the 2x squared, and is it minus 1? I believe it is. Minus 1. Okay, so that's the derivative of the secant inverse times now the derivative of e to the 2x, which is still e to the 2x, times the derivative of the 2x, which is 2. A lot of links to the chain there. So I took the derivative of the power on the outside. I took the derivative of the secant inverse. That was the next piece. Then I took the derivative of the e to a power. Then I took the derivative of the 2x, gave me 2. So if I had to clean this up, that's, like I said, a monster there. I'm going to combine the two e multipliers. That gives me a 4 times secant inverse of e to the 2x times a 1 over the absolute value of e to the 2x times the square root of e to the 2x squared, right? So if I square e to the 2x, that's really just e to the 4x minus 1 times another e to the 2x. And that would be my derivative. Now, I'm sure you can probably simplify that a little bit more, but like I said, they don't really test secant too often. I would leave my answer like that, especially on a free response. Okay, let's take a look at this one, though. This one I like a lot. I want to find y prime or dy dx for this problem. And so what I did is I combined both of these inverse trig functions with implicit. So if you notice, I have x's and y's in my problem. So we need to know how to do that. So cosine, I want you to take a look here, all right, is I'm going to, and you can see the original formula, 1 over, then it's negative. Be very careful. I have a negative out front. 1 over the square root of 1 minus x squared. So if I take the derivative of cosine inverse, okay, I'm going to get a 1 over, a negative 1 over the square root of 1 minus xy squared times, now the derivative of the inside, so I'm going to use a little product rule. So 1 times y plus x times 1 and dy dx, because we just took the derivative of y, equals the derivative of 1 is 0. So now I want to try to solve this for dy dx. So I'm going to begin by multiplying, or I can multiply or divide both sides by this fraction, but when I do that, so like if I divide negative 1 over the square root of 1 minus xy squared, right, from both sides, it's not really going to make a big difference, because 0 divided by anything is still 0, even if it's a variable. So I'm going to have a y plus x dy over dx equals 0. Subtract the y, so I have x times dy over dx equals a negative y, and if you divide, I get a dy over dx equals a negative y over x, and that is my answer. Okay, so I get a negative y over x. So again, when I took the derivative there, I had to use a little product rule. Always make sure we use chain rule appropriately, and you're taking the derivative using the appropriate methods. So this was, again, these are just more derivative formulas I need you to memorize. Feel free to put them on some note cards. Again, secant, cosecant, I'm really not concerned with. They won't be on my test, at least. I don't believe they're on the AP test either, but sine, cosine, tangent, and arc, cotangent, I do need you to know. Okay?